Hello and welcome to the answers to the Quiz 3 Review 1 with Mr. Roman. Problem number 1 says name 3 pairs of corresponding angles in the diagram. And here you could name the angles B, F was one pair. Another pair would be E, A. Another pair would be C, G. Another pair would be D, H. Another pair would be E, Q. Or FR, or HV, or TG, or LQ, or KR, or TM, or NV. The next one it says to name would be a pair, 3 pairs of alternate interior angles. So here you could say GR, you could say HQ, you could say D, L, you could say C, K, you could say K, T, or Q, N, or B, G, or E, D. Number 3 says find 3 pairs of alternate exterior angles. So you could say EV, you could say TF, you could say BM, or AN, or LV, or RM. You could also say FC, or AH. And then the last one, number 4, says find 3 pairs of consecutive interior angles. So you could say GQ, you could say HR, you could say GD, you could say KQ, you could say TN, or CL, or even DK. Then in problem number 5 it says draw the polygon ABCDEFG, and so that's the red polygon here. And then it says draw segment AC, which would be in green, segment AD, which would be in blue, and then segment BF, which would be in black. And then it says determine which pairs of angles are congruent in the diagram. Well, to be able to solve this, you need to know which sides of the polygon are parallel or not. So here, we just need to find the slopes of each of the sides of the polygon. Here, the slope between B and C is going to be negative 2/3. The slope between G and F is also going to be negative 2/3. The slope here would be 0. The slope of ED here would be a positive 1 slope. Slope of DC would be a positive 3 slope, and slope of AG would be a positive 3 slope, and then the slope of AB would be a slope of 7/5. So here, when you're looking at your diagram, you can say that the 2 lines here, so we can really say that this line here is parallel to this line, and we can say that this line is parallel to this line. Now because of that, let's go ahead and take out some of these other lines just to give it more clarity in the diagram. If you look at GF, the segment GF here, so here and then the segment BC, you can see that those 2 are parallel to each other. And then therefore, the angle here and the angle here are congruent because of alternate interior angles theorem. So we would say the angle CBF, so CBF is congruent to the angle GFB, angle GFB. Then we can look at the diagram. We know that side AG is parallel to side CD. And there's nothing really we can say is congruent here, because if we look at that set of parallel lines, that would be crossing like this. And if we wanted to use alternate interior angles, we'd have to do this angle and this angle, which we don't have that in the diagram, or we could do this angle with this angle, which also we do not have that in the diagram. So alternate interior angles would not work for the green line here. And then lastly, we have the blue line, which we can say this is parallel to this. And the angles that I'm looking at are going to be here and here are alternate interior angles. And so we would say that angle GAD, so GAD is equal to angle CDA. So CDA. So in each of the angles that we describe that are congruent, we know that they're congruent by the alternate interior angles theorem. Let's go ahead and take a look at number 6. So in number 6 here, it says to draw the polygon, which is a triangle, then draw the points M and L, and I've given the coordinates of points M and L. And then it says draw the segment ML, which in fact we know that ML is a mid-segment of the triangle because it connects two midpoints, which are M and L, of the triangle. And what we know about mid-segments of the triangle is that the segment ML is parallel to the segment ZY, and it's half of its length. So since those are parallel now, we can use that to say that angle XML is congruent to angle XZY. So angle XZY. And we know that by the corresponding angles theorem from this chapter. So that would be the first set of angles that are congruent. The other pair of angles that we know are congruent is angle XLM, which is here, and angle XYZ, which is here. And again, we know that because of corresponding angles theorem from this chapter. Now moving on to number 7, we have this kind of diagram, and all the angles here. We know that the two lines here, LM and KR, are parallel lines. And so therefore we can say that the consecutive interior angles of these parallel lines are add up to 180. So this angle plus this angle would equal 180. Or you could say this angle plus this angle would also equal 180. However, you would not be able to say that this angle plus this angle would equal 180. Or you would not be able to say this angle plus that angle equals 180. That would be incorrect here. And you have to really be careful when you're drawing these, or when you're saying which ones are going to add up to 180. Consecutive interior angles are angles that are going to touch, at least the ones that add up to 180, have to touch a pair of parallel lines. So here you have the 6x plus 8 and the 3x plus 1. They are both touching a parallel line in this diagram. And so they would be considered consecutive interior angles that add up to 180 degrees versus the two lines here, MR and LK. 6x plus 8 is touching that line, and 2x plus 27 is touching that line. We don't know that those two lines are parallel to start the problem, so therefore we can't say that they add up to 180 degrees. And the same kind of reasoning with 2y plus 12 plus 5y. We don't know that they are touching parallel lines, so we can't say that they add up to 180. Be careful there, and also make sure that when you're solving for x or y, the value of x and y does not have to come out to be a whole number answer. It can come out to be a decimal answer. So for this one, the only two equations you could actually write here would be this one or this one. And in both equations, you get x is equal to 19. And then once you find x in your equations, you can basically find all the angle measures of the diagram. And so I've labeled them on here in red. And we can see that the angle 115 and 115, the angle 58 and 115, those two don't add up to 180 degrees. Therefore, this line and this line are not parallel. Okay, if they were parallel, then this and this would have to add up to 180 degrees, but they are not. They do not add up to 180, so we cannot say that they're parallel. That would be the proof here. It was to say that the consecutive interior angles here and here do not add up to 180 degrees. Then on number 8, you have this diagram, and here you would want to be able to say that you're looking for alternate exterior angles here, and really the alternate exterior angles theorem says that if you have parallel lines that are cut by a transversal, so here would be a transversal cutting through two parallel lines, here would be a transversal cutting through parallel lines, you could say that this, the 5x plus 25 here at the top, and then the 5x plus 25 on the bottom are going to be equal to each other. But that really doesn't do us any good. We could also say that the 2y plus 14 and the 3y minus 4 would be equal to each other. Or we could say 7x minus 16 and the 6x plus 5 would be equal to each other. And those would be two ways to solve it. You would not, however, say that 6x plus 5 is equal to 5x plus 25 here. That would be incorrect. And those are corresponding angles, but they're not on a set of parallel lines. Those lines are in being determined whether they're parallel or not. So to solve this, you would set up two types of equations. The two types you could have were here and here. You should get that x is 21 and y is 18. And then here in the diagram, once you use x and y to find the angles in red, then you can see that the angle here and here, those are two different angles, and so therefore we cannot say that these two lines are going to be parallel because their corresponding angles are not equal. If they were equal, then we could say the lines were parallel, but they are not. Then on number 9, it says, write the equation of the line that is perpendicular to the given line, which is y equals negative 2x minus 1, passing through the given point. So the red line here is the equation y equals negative 2x minus 1. And we're saying we want to find the line that's perpendicular to that. Well, perpendicular is going to look like this. It's going to pass through at a 90-degree angle somewhere along this line. But we're also told that this green line, not only has it be perpendicular, but it has to pass through the point 4, 5, which is already on the graph here. So let's go ahead and put that there. And the way you would find other points for this graph is you basically start with the fact that you know perpendicular slopes have to be opposite reciprocals of each other. So here, if the slope of the red line is negative 2, so m in this one is negative 2, then the slope of my green line that's perpendicular is going to be a positive 1 over 2. So I can use that slope here from this point to find other points on the green line to graph it. And now I can just graph the line and then write the equation of the line, which here we know that the slope is 1/2, so we can say y equals 1/2 x, and then the y-intercept is simply going to be 3, so we can say plus 3 there. Then on number 10 it says write the equation of the line that is parallel to the line y equals 4, and then passing through the point 2, negative 1. So the red line here is the equation, or the graph of the line y equals 4, which you can also really just say that equation was y equals 0x plus 4, because the slope of this red line is really just 0. Now a line that's going to be parallel to that also has a 0 slope, so it's going to look like this green line here. And it's parallel somewhere in the plane, but we know that it has to pass through the point 2, negative 1. So here's what this looked like. That would be a 0 slope line passing through the point 2, negative 1. And then to write that equation, you simply say y equals 0x. The y-intercept is negative 1, so you could say that. Or you could simplify it to say y equals just negative 1 there for that equation on number 10. This concludes the review for the quiz, and I'll see you all on Tuesday.